In the last lecture, we discussed that a rational number is represented in the form p by q, where p and q are integers and q cannot be 0, and I asked you this question, why can't q be 0? So the reason behind this is that any number divided by 0 is still undefined, which means 1 by 0, 2 by 0, 3 by 0, or any number n by 0 is not defined. So that is why a rational number is represented in the form p by q, where q cannot be 0, and this is very important. Now there are some numbers on the number line which are not of this form, which means which are not of the form p by q, q is not 0. So these numbers are called irrational numbers. Such numbers cannot be written in the form p by q, where q is not 0. Now just like there are infinite rational numbers, in the same way there are infinite irrational numbers. So the set of irrational numbers is also infinite. Now square root of 2, square root of 3, pi, 0.0100, this is a non-terminating decimal. All of these are irrational numbers, and there are so many more. Now rational numbers plus irrational numbers together make up the set of real numbers, and this set is represented by capital R. So now this statement is very important, that every real number is represented by a unique point on the number line, which means every different point is a unique real number, and every unique real number is represented by a different point. That is why our number line is also called the real number line, because every point represents a real number. And what is real number? It is rational plus irrational. It's that simple. Now let's take a few questions from the exercises. The first question is, are square roots of all positive integers irrational? Which is false. For example, let's take 49. The question is, are square roots of all positive integers irrational? 49 is a positive integer and the square root is 7. And we know 7 can be represented in the form 7 by 1, where 7 and 1 both are integers and this is not 0. So 7 is a rational number. That is why the statement is false. Or for example, square root of 64 will be 8. 8 is a rational number. So this statement is false. Now the next question is, locate square root of 2 on the number line. So for this, we'll have to revisit the Pythagoras theorem. For example, Pythagoras theorem says that c square is equal to a square plus b square. So our Pythagoras theorem says c square is a square plus b square, which means c will be square root of a square plus b square. Now if we have a triangle where this side is 1 and this side is 1, so this side will be square root of 1 plus 1, which means square root of 2. So if this is 1 and this is 1, this side will be square root of 2. Now we have to represent square root of 2 on the number line. So this is my number line, this is 0, this is 1. Now if I make a triangle here where this side is 1 and this side is 1, so this is my triangle where this side is 1, this side is 1, so this side will be square root of 2. Now if I draw an arc with this as the radius, this is an arc, so this is the radius, this is square root of 2, so this is also radius, this will also be square root of 2. So which means this point is square root of 2 on the number line. Now how will you represent square root of 3? Now again, if we make a triangle, say this, if this is 1, this is 1, this will be square root of 2. Now if this is also 1, this will be square root of 3. Why? Tell me in the comments below how this is square root of 3. You again have to apply the Pythagoras theorem. Now to represent square root of 3 on the number line, what will I do? So this is my square root of 2. I'll make a line of length 1. And now again I'll use the Pythagoras theorem, so this becomes square root of 3. Now again with this as the radius, if I draw an arc, this will be my square root of 3. This might seem a bit complicated, but if you listen to this lecture again, if you listen again to what I've said, it's very, very simple. You just need to try it. So that was all for this lecture. Keep commenting below with all your doubts, all your queries, and I'll make sure I reply to all of them. Also, subscribe to this channel, like this video, share with your friends, and thank you for watching.